Hi, I'm going to tell you a few things about the Parabola's PowerPoint, just to give you a better idea if this was taught to you when I had a substitute teacher and perhaps the teacher didn't explain what was going on with each slide and you were just writing down information. Or for those of you that did have this lesson taught by me in class but just need to go back and hear some of the explanations again. So I'm just going to go through some of the slides. I'm going to start with this one that's talking about the sketch of a basic parabola. This one's obviously opening up, so it's vertical, but it has all the parts to the parabola when we talk about a parabola as a conics section. So the focus is a point that's always inside the curve of a parabola, whether it opens up, down, left, or right. The directrix is always a line that's outside the curve of the parabola. It's never touching the parabola. It's perpendicular to the axis of symmetry. That's why you're seeing this right here. And then what the definition of a parabola really is, what gives it its natural shape, is that every point along this curve, and we've got one right here that's pointed out to you, every point, if you were to measure its distance from the point to the focus point and perpendicular to the directrix line, those distances always have to be the same measurement. So that's what we call equidistant. So this is just one point among many that are along, infinitely many, along this curve of the parabola. So this one right here, this distance from the vertex to the focus point and from the vertex to the directrix line, it's a special distance, and I call that lowercase d, and that's the one formula that you're going to have to memorize for parabola conics sections. Is d is 1 over 4 times a. A is just the value that's in front of the squared term when it's written in, perhaps you've called it vertex form in the past. I'm going to call it the standard form of a parabola conics section because that's what I want you to put it into, that form, when you have to complete the square. And you'll see some examples of that later on. So whether you want to call it the standard form of a parabola conics section or vertex form of quadratics, either way, A is the value that's in front of the squared quantity. Okay. So let me just jump to that at this point. Where was it? Right here. So D is always going to be that distance from the vertex point to the focus point inside the curve and outside the curve to the directrix line. That's always 1 over 4 times A. Okay. Later on in the last examples, I'm asking you to write the equation of a parabola given some information. When we get to those, we're using this formula over here. If you took this formula on the left-hand side and solved it for A, you would get this one over here. So these are really nice and easy to remember. D is 1 over 4A, A is 1 over 4D. Okay? So let me get to an actual graphing one, or let me scroll down to number 13, slide 13. This one. So perhaps you didn't understand what was going on here, but remember the definition of a parabola is the set of all points on this curve that are equidistant. So this distance right here would be the same as this distance perpendicular down to this line, the directrix line. There's only one set of special points on the entire parabola that are exactly twice the distance of D that we find using that little formula, 1 over 4A. So and that's because we can form a square from this. So if this is D, the distance is D from the vertex to the focus point here. It's also the same distance D from the vertex to the directrix line. So this is 2 times D. D plus D is 2D. So if we were to create a perfect square out of this, these are the only 2 points on the entire parabola that are exactly twice this distance D. That's because this is perpendicular, that's perpendicular, this is perpendicular, that's perpendicular. So later on, when I'm asking you to graph the parabolas, we no longer have to make a table of values every time. We can know which direction it should be opening just by looking at it, and you'll get practice at that. And finding the vertex, being very careful when it's a horizontal parabola, because it's really easy to mix up H and K. I'll talk more about that in a minute. But then we just plot the vertex. We're going to draw the axis of symmetry line through it and label it. We're going to find out what the value of D is by taking 1 over 4 times A and figuring that out. We're going to go that distance inside the curve, depending on which way it's opening. Plot our focus point. We'll go in the opposite direction from the vertex and graph our directrix line. And then we'll take that distance d and we'll double it and we'll go out from the vertex. We may be going left or right if it's opening up or down, or we'll be going up or down if the parabola is opening left or right, if it's a horizontal one. Okay, so these are the only special point. They're the only 2 points like this on the parabola. All of the other ones are not exactly 2 times d. These are the only 2 ones. So if you know the vertex and those 2 additional points, you can graph the parabola and not have to make a table of values. Okay, so that was the whole idea behind this. So let's go to it. I'm going to jump to the first graphing example, and I'll put it back in slideshow mode so you can see it step by step. So here we have a parabola, and your notes had a side section called Cornell notes available to you. If you've never taken Cornell notes before, that is a space where you can write questions to yourself, but I kind of think of it as an extra little notepad. I like to write down observations that I notice about what I'm working on. So in this case, I notice I have y equals, and it's x being squared. That's a vertical parabola. You're already familiar with those. It's the x equals then the y squared that you were never familiar with, perhaps not familiar with before. Maybe you've studied them in the past. Okay, but these are the, in general, these are the ones that you're familiar with, more familiar with, the vertical ones, the ones that are opening up or down. So I'm looking at this, and so on the side margin I could write, you know, this one's going to open down, and obviously I'm going to have you identify that right here. Because it's y equals and we have x squared, it's going to be vertical. I know it's going to open down because this is negative. This is a right here. Negative 1/4 is a. So anytime it's negative, it's going to open down if it's a vertical parabola. It would open left if it was a horizontal parabola. So positive a, up or right, negative a, down or left. So this one's going to open down. So right away, before I do anything else, I would go off to the left margin and I would sketch just a little curved parabola that's opening down. I'd put some kind of little point and call it capital F for focus inside it. I'd go the other direction and draw a horizontal line out there and call it capital D for my directrix. I would know that the axis of symmetry line is going to go straight through that parabola, so it's going to be vertical. And I know my additional points are going to be twice whatever D was, and they're going to go out left and right from the focus. So I would have that little sketch off to the side before I even get to actually graphing this. So what I've mentioned in the past to you guys was that anytime you have a number in parentheses with an x, we call this value h. H is always associated with x. K, if there is a k, in with a y, that is always associated with y. So anytime you have something in parentheses with x, think, this has got to be the x coordinate. And in this case of the conic section, the parabolas, we have a vertex. All of the other conic sections that you're going to study, we don't have a vertex, but it's called the center. So you'll be studying ellipses circles next, and then ellipses, and then hyperbolas. They would all have centers. This is the only one that has a vertex. But guess what? They're always HK. So H is always the X coordinate. K is always the Y coordinate. So again, I would ask you, because this is in parentheses, where'd my little cursor go? What value would make this 0? And you would tell me, positive 5 would make that 0. So 5 is going to be the X coordinate of the vertex. And then out here, what you see is what you get. If this is positive, this is positive. This is going to be the y coordinate. If this was negative, that would have been negative. So my vertex is going to be 5, 2. We're going to come over here to 5, 2 and plot it. We're going to label it with a capital V. I've already drawn a sketch out there. I know that I'm going to have a vertical axis of symmetry. So you see how I just label it with these little, you know, can't even think anymore, sorry. I'm just labeling them very basically on my graph with letters, and then I'm going to come over here and identify the actual equation of that line. It's x equals 5. Okay, so now I'm ready to find d, this lowercase d. What is the distance from the vertex inside the parabola to the focus point and outside the curve of the parabola to the directrix line. So I know it's the formula 1 over 4a. This is a. A is whatever was in front of the squared quantity when it's written already in this form. If it's not, we have to do a little bit of work first. So 1 over 4 times negative 1/4. Well, that's just 4/4, right? Negative 4/4 is negative 1. And 1 divided by negative 1 is just negative 1. And again, we should expect that this was negative because it's opening down. So whenever the parabola opens down or left, you're going to get a negative value for D. Now, when in your homework, I'm asking you in the little box to label all these things that you're doing, that you're graphing, you would go ahead and label that -1. But we know we're talking about a distance on the graph, and so we would ignore the sign. So we're going to go 1 down and plot the focus point, and 1 out the other direction for the directrix line. And you would have had something drawn like this in a sketch off on the side, correct? Always do a sketch. I'm telling you right now, it will save you the hassle of making mistakes. Drawing the little sketch out is going to help you avoid some of these mistakes. Okay, so now we've got that. What now? We need our 2 additional points. Oh, and by the way, I can go ahead and label these. What is the coordinates of that? 5, 1. And the directrix line is y equals 3. Okay, so you're not seeing where I'm labeling the 2 additional points, but we're going to go 2 times the absolute value of D. Okay, I must have an older version of PowerPoint on my computer here. This is missing its absolute value symbol, so you're probably seeing the same thing I am, and therefore I didn't have math type on my home computer, so no big deal, we can deal with that. Just ignore this sign and double that. So it's 2. So we're going to go left and right 2 units. Don't go 1. And by the way, if you go from the vertex, because I've seen students do this time and time again, if you go out from the vertex, your parabola is not going to look right. It would have this, you can't have a long flat bottom like this for your parabola. That just will not work. That does not look like a parabola. Are you with me on that? So if you do that, you make that mistake, oh yeah, wait a minute, I got to go back. I got to go from the focus point, not the vertex. So go left and right 2 units, and then draw your parabola through those 3. You're good to go. Label them. This was at 3, 1, and this was at 7, 1. So you're finished with this one. By the way, another mistake I see a lot of students make is they'll just take D, and since D was 1, they'll just go out left and right 1 also. You can't do that. Remember, the additional points are, you got to go back to what is the definition of a parabola. It's every point on the parabola has to be equidistant from the directrix line and the focus point. So this would have to be 2 and 2. This is 2 and 2. This one is 1 and 1 because the vertex is a point on your parabola, so it follows the definition also. This is equidistant also. But these are the only 2 points that are exactly double the distance of D. So that's it for this one. Let's move on to the next one. Now you should be noticing, this looks different than what I'm used to. Oh, it's x equals. That's going to be horizontal. And because it's negative a, it's going to open left. So immediately go off to the side, sketch a parabola that looks like it's opening left, go inside, put a little focus point, up and down. That's going to be your 2 additional points. You're going to have a horizontal axis of symmetry. You're going to have a vertical line for a directrix line, and go off that sketch now. So here's another thing. When you have horizontal parabolas, you have to be very careful of HK. If there's something in parentheses with Y, you got to be thinking, it's with Y, it's with Y. Y coordinate of the vertex. So this is going to be your X coordinate. What you see is what you get. So that's going to be 4. And if this is with Y, what makes that 0? Positive 2. And it's with Y, Y coordinate. So it's going to be 4, 2. Plot it. Label it V for vertex. Put in your axis of symmetry line. Now go out, and we need to find the focus distance and the directrix line distance. So we're going to do 1 over 4 times A. A is negative 4/12. What's negative 4/12 if you multiplied 4 times negative 1/12? Negative 1/3 right? So what's 1 divided by -1/3? We don't want to divide by a fraction. Multiply by its reciprocal. You get 3. Go a distance of 3 inside from that because it's opening